This video covers Notes 9.1 over graphing two variable inequalities. So we have two examples shown. If you notice, these equations or these lines are exactly the same. They both start down at -5. They both have a slope of up to right 1, up to right 1. Excuse me. But the shading of these two graphs is different. So that's what they're asking. What do you notice about the shading of these two graphs? Well, if I look, the shading for this graph is like underneath or below the line. And if I look at the symbol, we have a less than sign. So a less than sign shading is below or underneath, whatever word makes more sense to you. Whereas the other line, it goes above the line. So we have the line and the shading is above or on top of, and a greater than sign. Excuse me. So we have two different inequality symbols and two different types of shading for the exact same line. So when we are graphing two variable inequalities, determining the shaded region is based off of your inequality symbol and the direction that it points. So we have three steps for solving. Three steps for graphing. First is to solve for y if needed, because we can't graph a line if we don't know what y is. The second one is to graph the line. It's a solid line. Solid line if you have the lines under the inequality, or dashed if there is not a line under the inequality. And then the third thing is to do your shading to determine your shaded region and do the shading on your graph. So for this first example, it's already been done for us. We have y is less than or equal to -2x minus 3. So my slope is with x, -2. My b value is what follows. So I go down to -3 and then go down to right 1, graph a point, down to right 1, graph a point. So that's where the line comes from. That part is staying the same. Next, I have a solid line because there is a line under my inequality symbol. So instead of a filled in bubble, we have a filled in line this time. So I have a solid line as opposed to a line that looks like this. And then my shading, I have, if you ignore the slope in order to shade by hand, and we just look at y compared to your y-intercept, we have y is less than or equal to -3. Well, less than -3 on the y's would be -4, -5, -6, -7, -8, -9, -10, and so on. And so we shade everything underneath the y, which is also underneath the line. So that's where the shading comes into play. Now, the good news for you is that this year we have some steps on how to graph these in the calculator to see your shading if you're struggling. So I'm going to show you those steps as we graph number 2. If you've already been to class, you should have a sheet of paper that tells you these steps to graph in the calculator. If you haven't been to class, then you need to look in Schoology for the steps that say how to graph inequalities in the calculator to see these steps that I'm doing. Excuse me. So first, we need to solve for y. Well, y is already on its own, so I identify my slope of 1/2 and my b value of -3. So I'll go down to -3. My slope is up 1, right 2, up 1, right 2, up 1, right 2. The line is going to be a dashed line because there is no inequality or no equal to sign underneath the inequality. So I do a dashed line. Another option for you is to do a filled in line and then erase, but I don't recommend it because students forget to erase. Now the shading I can use my calculator for. So what I'm going to do in my calculator is go to y equals, and I'm going to plug in this inequality like I see it. So I have a fraction of 1/2 x minus 3. Now, before I click graph, I'm going to scroll all the way to the left until this little arrow or backslash is flashing. So for the graphing in a calculator, a greater than sign goes above the line and a less than sign goes below the line. And you do have to know that whether you're graphing by hand or graphing in the calculator. So this is a a greater than sign. I know that because less than looks like an L, so that's a greater than sign. So my shading is a greater than sign, which means I need to get the option in the calculator that goes above. What I mean by that is when I click enter, if you watch this backslash, when I click enter, the slash has changed. Now this is an above. This is a greater than sign. So a greater than sign, the calculator is going to look like this. A less than is going to look like this on the bottom. So if I click enter again, that would be a less than. So I click it 2 times to see the greater than so that it will do the shading for me. So I'm going to click graph now. And I can see the line that's right here. It will not tell you if it's dashed or solid, so you do need to know that. But I can see now that the shading in the calculator is above my line, so I will shade everything above my line. So you can let the calculator show you how to graph it, but you will still have to put points on here, and you will still have to do the shading. You cannot leave these graphs blank. So for problem 3, I start down at -4 because that's my b value, and I go up 1/1 a couple times. My line is going to be dashed or not complete. It's not a solid line because there is no line under the inequality. And then for the shading, we have a greater than sign, so I need to use the above in y equals. So in y equals, I have x minus 4. Now notice my shading went away when I cleared that out, so I need to go back over and click the one that will go above or on top of. And I click second graph, and it will, I just click graph, and it will graph the line for me and show me or remind me that my shading is above the line, so I can use this to make sure I am graphing things correctly. Now, if you don't have a calculator at home, then you would just say, y is greater than 4, greater than -4 greater than -4 goes above on the y-axis, and you would shade accordingly. Problem 4, my m value is -2/3 and my b value is 5. So I start up at 5 and I go down to right 3, down to right 3, down to right 3 a couple of times. My inequality symbol has a line underneath the inequality, so this is going to be a solid line. And then for my shading, y is less than 5. So I can use my brain or I can use the calculator, whichever one you prefer. So I have -2/3 x plus 5. And then this time I need to be a less than. So less than is below. So I'm going to click enter until I see the shading that is underneath the line. And I'm going to click graph, and it's going to show me my line and show me that it's shaded underneath that line. Now please keep in mind, if you go to y equals, this line right here is not supposed to be representative of the line you have drawn. This piece right here is just showing you underneath or above the line that was already shown. So this is not like, oh, my line looks like that. My line is decreasing with a negative slope. That's the one I need. So please don't think that. You need to know whether it's greater than, so above, or less than, so below. Now, when we're looking at inequalities with two variables, we've plotted these. We have a solution, so this is our shaded area for the graph that is shown, and they are asking me for the points that would be solutions to the above inequality. So this is the inequality, y is greater than or equal to x. We go up. If you wanted to, you could graph this. It's not really necessary because it's already graphed for you. But if you wanted to, this is a greater than sign, so we would go above. And we would see the exact same thing on our paper. Now, the shaded region is known as the solution region because all points that lie on the region represent solutions to the inequality. So my possible solutions are A, because it's in the shaded area, B, because it's on the line, and C, because it's in the shaded area as well. E is outside the shaded area and D is outside the shaded area. So D and E would not be solutions because they are not in the shaded area. Now, if you don't have a graph to graph this on, you can use point testing. So you can also test if a point is a solution by plugging in X and Y to determine if the inequality is true. So we are asked, is the point 4, -6 a solution for this inequality? And they have plugged in -6 for Y and 4 for X, and we need to determine if this is true. So what I'm going to do is I'm going to simplify this. On the left side, there's nothing to simplify. On the right side, we have 2 times 4 minus 2. So I'm just going to plug that into my calculator like normal to get that I have 6. Now, is -6 greater than +6? If the answer is no, then it is not a solution. If the answer is yes, then it is a solution. So you can use point testing if you don't have a graph or don't feel comfortable graphing. You can plug in your X and your Y to see if the inequality is true. If the inequality is true, then it is a solution. If the inequality is not true, then it is not a solution.